Hello, welcome back to Sushi Live Noding. In this episode, I'm going to be recreating a ping pong motion or animation, or basically the value that's changing from one value to another value and back to the original value, back and forth in linear fashion. I will be using Sverchok add-on and build it from scratch, but I'll give you a quick demo first using animation nodes, because animation nodes already come with a ping pong motion. So if we are using like a frame and then using repeat time, we have loop, but we also have ping pong. This is like a two interesting value that we often use. So if we plug in frame into time and then use this time value, you will see something interesting. So transform output. So we have this box in the 3D scene. So just pick the box, and this time can go into the one of the location. So let's try just plug it into the X, delete everything else, and play back. So you will see that thing is keep going through until it hits 50 and goes back to 0. So that's because of the loop. Loop in the mathematical functions, we often use modulo, but ping pong is an interesting one. See, ping pong is just giving like this linear back and forth motions. So this is something that I'm trying to recreate. It's not a sine wave. Sine wave, if I actually draw it, ping pong is more like this. If this is a time, and this is a value between 0 and 1, this is ping pong. Sine wave is more like something like this. So it goes under and then goes up. This is by default. So let's recreate the ping pong motions. There is actually an answer here on the unity.com. This is actually the functions that you need to recreate a ping pong motions. Seems like pretty complicated, but it's not actually that hard. I'll explain after I recreate this using nodes. So let's just get started. Switch to Sverchok, switch on, and delete everything and save it as ping pong demo. So it shouldn't be too hard. Basically, with a ping pong motion, you need some kind of length. You start with the length, and then you're using the time with the modulo. And there's this some kind of expression. So if it's under 0, or actually if it's bigger than 0, return t. If it's else, return l minus t. So there's a few variables, but we gotta turn this into nodes. So we're gonna start with length. So a length is a variable, and for a variable to work inside a node, you just create a number. I'll be using just a number. Give it a number of 5. So this guy is gonna be the length. I'm just gonna rename it, give it a label. So this is a length. Length times 2 is gonna be L. Okay. So math, this guy multiplied by 2 is gonna be L. Okay, so that's L. T equal time modulo L. So we need time modulo L. First of all, for time, we're gonna be always using frame info, but you can use any number. Modulo L. Okay, we need another math function. This is gonna be modulo. Actually, just use a new one. Modulo. Okay, so this is time modulo L. This is L. So times modulo L, it's gonna be T. I will be using Control J and give it a label this way actually. So you can see there's a T. Actually, for this guy as well, I'm just gonna remove the label, Control J, give it a L. Okay, so now this is getting somewhere because we have all the variables. We now just need to try to recreate these expressions. There's a bit of logic. So this is if blah blah return this, or else return this guy. So we need to do that. There's also this L minus T that I will recreate on the fly. But for now, let's do this one on the top. 0 smaller or equal T smaller than length. So this guy, I will be using logic. So logic function. This is going to be greater than, let me check. T greater than equal. T, where is T? This guy. T greater than or equal to 0. And T should be smaller than length. T smaller than length. T smaller than length. Length is this guy. Not the L, but the length. Be careful. Okay, cool. If both conditions are correct, we're gonna use it for switch. So it's gonna be for the state. State is gonna be 0 or 1. The true or false is gonna be this value. Return T. So T is easy one. Just plug in the T. If it's false, return L minus T. So another math functions. It's gonna be L minus T. So this is going to be subtracts. Where's subtract? Sub. Plug this into the false. So I think if I'm doing everything correctly, this is going to be the value that we need. So let's use the vector in. Plug this into the X. And then use the viewer draw. And let's see. I'm just going to plug it into vertices for now. And just run it. You can see very small points there. A point going back and forth, 1, 2, 3, 4, 5, within 5 units. 1, 2, 3, 4, 5. Yep, I think that's correct. And it's a bit fast. I'll slow it down. So now all these nodes represent the ping pong motion or ping pong value. If we investigate the value, really, I'm gonna be using stethoscope. This is our frame, right? Frame keep going up. I'll increase this to 10,000 frame. So it's gonna, the number just keep going up. But this is the ping pong functions. It's gonna turn our frame into a ping pong number, which is this guy over here. It goes really fast. So I will slow it down using math. Here, just multiply it by 0.1. So now it's much slower, and you can see the value goes from 0 to 5 back to 0 in a linear fashion. And we can at any time change the length. Let's make it a 3 or 4 or 3. Now it's gonna go between 0 and 3 and back to 0, and it's gonna continue on and forever, right? So this is a ping pong motions, and we got it here already. And let's see if we want to use it. Let's try it on Suzanne, for example. I'm just gonna plug this vector into the matrix and then use Suzanne head. Now we can see Suzanne going back and forth in x-axis. Suzanne head by default is facing the y negative axis, so we're gonna try just doing that. Plug this into the y. So now Suzanne moves back and forth between 0 and positive 3. Let's increase the value into 8 8 is good number, and increase the speed. Actually too fast. So I think this one looks kind of nice, but Suzanne is always pointing in one direction, so it's like move back and forth. But we can perhaps improve this. If you want to kind of flip Suzanne, it shouldn't be too hard. Let me try doing that real quick. So we have this transform matrix for Suzanne. So if I'm using matrix in, this guy is gonna be the location, but for the rotation, we can perhaps rotate Suzanne 180 degree whenever it hits the peak of the corner. So let's use another switch and have a float value. This is going to be 0 and this is going to be 180. So this is going to be the value of angle. You know, Suzanne is going to be flipping between two values. So two state, 0, 0 and 1, 0 and 1. So we're gonna just flip the state, and for that we can use the ping pong. Ping pong is doing this. Okay, now it's doing it backward. We just need to change the value. Okay, now it's it works. We have Suzanne moving back and forth forever, as long as the time keeps going. It's an interesting motion, I think, and you're gonna use this a lot. It's a linear motion. It's kind of boring, and it's gonna be like a kind of like a snap. It changes direction without any kind of interpolations, but you use this a lot. I think especially in the game engine, this ping pong thing is a very common function. So all these nodes can be combined into just a single node. I think eventually someone, maybe Sverchok developer or maybe me, I don't know, someone will turn these ping pong functions into a single node. It should be part of the math. It should be here. If it's already there, I probably missed it. We have sine, of course, and we have modulo, and we need a ping pong, I think. But ping pong is more like a specialized. So ping pong is more like a modulo, but it's repeating time value. So anyhow, so that's pretty much how I recreate ping pong functions for Sverchok. It's really based on this function. This is a very general common function. Should be there already. But there you go. That's how we build it from scratch. Thanks again for tuning in, and I'll see you next time. Bye.